Hello, my dear cosmic travelers, and welcome back to Sleepy Scientist. I'm so grateful you've chosen to spend this peaceful evening with me, settling into your comfortable space as we embark on perhaps our most extraordinary journey yet, a gentle exploration of what might happen if you could somehow fall into one of the most magnificent stars in our night sky, the beautiful red giant Arcturus. Take a moment right now to get truly comfortable, whether you're nestled under soft blankets in bed, resting in your favorite chair, or lying peacefully on a couch. Allow yourself to settle in completely. Feel your body relaxing, your breathing naturally slowing as we prepare to journey together beyond the bounds of Earth, beyond our solar system, to visit one of the most ancient and majestic stars our galaxy has to offer. Tonight's exploration is a thought experiment, a peaceful meditative journey through the cosmos that will help us understand not just the magnificent star Arcturus, but also our own deep connection to the stellar processes that created the very atoms in our bodies. We're going to discover that falling into a star isn't the violent, destructive event we might imagine, but rather a gentle transformation, a return to the cosmic processes that gave birth to everything we know and love. There's something profoundly comforting about understanding our cosmic origins, about recognizing that we're not separate from the stars we see twinkling in the night sky, but intimately connected to them. Every atom in your body, the calcium in your bones, the iron in your blood, the oxygen you're breathing right now was forged in the nuclear furnace of an ancient star. In a very real sense, you are stardust contemplating stardust, a conscious part of the universe becoming aware of itself. Arcturus, our destination tonight, is a perfect star to help us explore these cosmic connections. It's one of the brightest stars visible from Earth, a brilliant orange-red beacon that has guided travelers and inspired dreamers for thousands of years. But Arcturus is far more than just a bright point of light in our sky. It is a world unto itself, a massive sphere of plasma and energy that represents one of the most beautiful phases in stellar evolution. Picture yourself for a moment standing outside on a clear spring evening, looking up toward the constellation boats, the herdsmen. They're blazing with warm orange light is Arcturus, so bright that it's often the first star to become visible as twilight fades, so distinctive in color that ancient observers named it the Bear Guard because it appears to follow the Great Bear constellation across the sky. But what you're seeing when you look at Arcturus is light that began its journey from that distant star about 37 years ago. The photons entering your eyes right now started their journey when you were much younger, or perhaps before you were even born. They've traveled through the vacuum of space for decades to reach you, carrying with them information about a star that's fundamentally different from our own sun. Arcturus is what astronomers call a red giant, a star that has evolved far beyond the stable middle age that characterizes our sun. At roughly 7 billion years old, Arcturus is ancient by stellar standards, older than our entire solar system. It's a star that has lived long enough to exhaust the hydrogen fuel in its core, forcing it to evolve into something larger, cooler, and more luminous than the yellow dwarf star it once was. This evolutionary process is one of the most beautiful stories in astronomy. Imagine a star like our Sun, steadily converting hydrogen into helium in its core for billions of years, maintaining a careful balance between the inward pull of gravity and the outward pressure of nuclear fusion. This balance creates what astronomers call the main sequence phase, a long, stable period when a star shines with consistent brightness and temperature. But eventually, as billions of years pass, the hydrogen fuel in the star's core begins to run low. The nuclear furnace that has powered the star for so long starts to sputter and fade. Without the outward pressure of fusion to support it, the star's core begins to contract under its own gravity. This contraction heats the core, and hydrogen fusion begins in a shell around the now helium core. This shell burning is more vigorous than the core burning that sustained the star during its main sequence phase. The increased energy output causes the star's outer layers to expand dramatically, sometimes to hundreds of times their original size. As these outer layers expand, they cool, changing the star's color from the hot blue, white, or yellow of its youth to the warm orange and red hues we associate with giant stars. Arcturus has undergone exactly this transformation. What was once a star similar to our Sun has evolved into a red giant, approximately 25 times larger in diameter. If Arcturus were placed at the center of our solar system, its surface would extend well beyond the orbit of Mars, engulfing Mercury, Venus, Earth, and the red planet in its expanded envelope. Yet despite its enormous size, Arcturus is only about 1.1 times more massive than our Sun. This means it's much less dense than you might expect. Imagine taking all the material of our Sun and stretching it out to fill a sphere 25 times larger. The result would be a star with an average density much lower than our Sun's, more like a cosmic soap bubble filled with hot, glowing gas. This low density is crucial to understanding what would happen if you could somehow fall into Arcturus. Unlike the solid surfaces we're accustomed to on planets, stars don't have distinct boundaries where space ends and the star begins. Instead, they have atmospheres that gradually become denser as you move toward the center, transitioning smoothly from the vacuum of space to the dense, hot plasma of the stellar interior. As we begin our journey tonight, I want you to imagine this process not as a violent collision or catastrophic event, but as a gentle merger, a peaceful transition from being a separate entity moving through space to becoming part of the star itself. In many ways, it's similar to what happens when you wade into a calm lake. You don't crash into the water's surface, instead, you gradually become immersed, the boundary between you and the water becoming increasingly meaningless as you move deeper. Our imaginary journey to Arcturus will unfold in stages, each revealing new wonders about stellar physics, cosmic evolution, and our own deep connection to the processes that govern the universe. We'll start by leaving Earth and traveling through the vast emptiness of interstellar space, appreciating the incredible distances that separate us from even our nearest stellar neighbors. Then we'll approach Arcturus itself, observing how this magnificent star appears to change as we draw closer, growing from a point of light to a disk, then to an enormous sphere of glowing gas that fills our entire field of view. We'll explore the different layers of the star's atmosphere, understanding how temperature, pressure, and density change as we move from the tenuous outer corona toward the dense, hot interior. Most importantly, we'll discover how the journey into Arcturus represents a return to our cosmic origins. The elements that make up our bodies were created in stars like Arcturus, forged in the nuclear fires of stellar cores and distributed through the galaxy when those stars reached the end of their lives. In falling into Arcturus, we're essentially returning home, rejoining the stellar processes that gave us birth billions of years ago. This perspective transforms what might seem like destruction into something far more beautiful, a cosmic recycling process that ensures the elements of life continue to flow through the galaxy, eventually becoming part of new stars, new planets, and perhaps new forms of life. When we fall into Arcturus, we don't disappear, we become part of something larger and more eternal. Our atoms joining the stellar dance that has been going on for billions of years, and will continue for billions more. Throughout our journey tonight, we'll maintain this perspective of wonder and connection rather than fear or destruction. The universe is not a hostile place trying to destroy us, but rather a vast, interconnected system of which we're already a part. understanding our relationship to stars like Arcturus helps us appreciate both the grandeur of the cosmos and the preciousness of our existence as conscious beings capable of contemplating our own cosmic origins. The story of falling into Arcturus is also a meditation on time scales that extend far beyond human experience. This ancient star has been shining for longer than our solar system has existed. It will continue to evolve and change long after human civilization has become part of cosmic history. Yet, in our brief moment of cosmic consciousness, we have the remarkable ability to understand and appreciate these vast scales, to find meaning and beauty in processes that dwarf our individual existence. As we settle into our exploration tonight, I invite you to embrace this cosmic perspective. Let go of the concerns and stresses of daily life, the small worries that can loom so large in our human-scale experience. Instead, allow yourself to be carried away by the grand sweep of cosmic evolution, the patient processes that have been unfolding for billions of years, and will continue for billions more. Feel yourself connected not just to the Earth beneath you, but to the solar system spinning through space around our Sun, to the galaxy rotating slowly around its center, to the universe itself, as it continues its ancient expansion and evolution. You are not separate from these processes, you are part of them, a conscious expression of the universe's capacity for self-awareness and wonder. The journey to Arcturus we are about to undertake together represents more than just a thought experiment about stellar physics. It's an invitation to see yourself as part of the cosmic story, to understand that your existence is intimately connected to the life cycles of stars, the formation of galaxies, and the fundamental processes that govern reality itself. Arcturus waits patiently for our visit. This ancient red giant that has been converting matter into energy and light for longer than our world has existed. Its warm orange glow beckons us across the light years, inviting us to discover the secrets of stellar evolution, the beauty of cosmic recycling, and the profound truth that we are all temporary arrangements of stardust, briefly conscious and capable of wonder before we return to the stellar processes that gave us birth. Tonight, we'll answer that invitation. We'll journey together across impossible distances to visit one of the most magnificent stars in our galaxy. We'll discover what it means to become part of a star, to merge with the cosmic processes that created us, and to find peace and meaning in our connection to something infinitely larger than ourselves. So settle in comfortably, dear cosmic travelers. Take a deep, slow breath and feel yourself beginning to relax into this gentle exploration. Our journey to Arcturus is about to begin, and it promises to be one of the most beautiful and meaningful adventures we've shared together. The red giant awaits, ancient and patient, ready to teach us about stellar evolution, cosmic recycling, and the eternal dance of matter and energy that connects all things in our magnificent, ever-evolving universe. As we settle more deeply into our cosmic exploration, let's take time to truly understand our destination, Arcturus, the magnificent red giant that will be our host for this extraordinary journey. Understanding this ancient star's nature, history, and place in the cosmic order will help us appreciate the profound experience that awaits us as we imagine falling into its stellar embrace. Breathe slowly and comfortably as we paint a detailed picture of Arcturus together. Imagine you're floating peacefully in space, perhaps seated in a comfortable cosmic observatory with perfect views in all directions, completely safe and able to observe the universe around you with wonder and appreciation. Arcturus is located approximately 36.7 light-years from Earth in the constellation Bodes. In cosmic terms, this makes Arcturus one of our relatively close stellar neighbors, close enough that ancient astronomers could track its motion across the sky over centuries of careful observation. yet far enough away that the light we see from Arcturus tonight left that star during the mid-1980s. To put this distance in perspective, imagine that our entire solar system, from the Sun out to the orbit of Neptune, is reduced to the size of a coin. On this scale, Arcturus would be located about 600 miles away. The vast emptiness of interstellar space becomes apparent when we consider these scales. The journey from our solar system to Arcturus would take us through regions where matter is so sparse that we might travel for millions of miles without encountering so much as a single atom. Yet Arcturus blazes across this vast distance with such brilliance that it ranks as the fourth brightest star in Earth's night sky. Only Sirius, Canopus, and the Alpha Centauri system outshine this distant red giant. What makes this brightness even more remarkable is that Arcturus achieves it not through proximity, but through sheer luminosity. It's actually pumping out about 170 times more light than our Sun. The color of Arcturus immediately sets it apart from our familiar yellow Sun, where our Sun appears white or slightly yellow when viewed from space. Arcturus glows with a warm orange-red hue that speaks to its different surface temperature and evolutionary state. This color isn't just aesthetically beautiful, it is a direct indicator of the star's surface temperature, which averages around 4,300 Kelvin compared to our Sun's 5,800 Kelvin. This cooler surface temperature might seem to suggest that Arcturus should be dimmer than our Sun. But remember that Arcturus is enormous compared to our star. Imagine trying to heat a small room versus a vast warehouse. Even if the heating elements in the warehouse are cooler, the total amount of heat produced can still be much greater, simply because there are so many more of them distributed over a vastly larger area. The stellar classification system places Arcturus as a K 1.53 star. The K designation indicates its orange color and surface temperature, while the 3 indicates that it is a giant star, much larger than a main sequence star of the same temperature. The decimal designation of 1.5 places it on the cooler side of K-type stars, approaching the boundary with M-type red giants that are cooler still. Understanding Arcturus's evolutionary history helps us appreciate what we're seeing when we look at this magnificent star. About 7 billion years ago, when our solar system was still a disk of dust and gas surrounding our newly formed Sun, Arcturus was already an ancient star beginning its transition from main sequence stability to giant phase expansion. The star that became Arcturus likely started its life as a main sequence star, somewhat more massive than our Sun, perhaps 1.5 times our Sun's mass. For billions of years, it steadily converted hydrogen into helium in its core, maintaining the delicate balance between gravitational collapse and fusion pressure that characterizes stable main sequence stars. But eventually, as happens to all stars, Arcturus began to run low on hydrogen fuel in its core. As the nuclear fires began to die down, gravity gained the upper hand, causing the core to contract and heat up. This contraction triggered hydrogen fusion in a shell around the now helium core, and this shell burning proved to be much more vigorous than the original core fusion. The increased energy output from shell burning caused Arcturus's outer layers to expand dramatically. As these layers expanded, they cooled, causing the star's surface temperature to drop and its color to shift from the blue-white, or yellow of its youth, to the warm orange-red we see today. The star became what astronomers call a red giant, enormous in size, moderate in surface temperature, but tremendously luminous due to its vast surface area. This evolutionary process didn't happen overnight. The transition from main sequence star to red giant likely took millions of years, with Arcturus gradually growing larger and cooler as its internal structure reorganized in response to the changing fuel situation in its core. Today, we're seeing Arcturus in this mature giant phase, a stellar elder that has successfully navigated one of the most dramatic transitions in stellar evolution. The internal structure of Arcturus is fascinating to contemplate. At its center lies a dense helium core, perhaps 20% of the star's total mass compressed into a region no larger than Earth. This core is incredibly hot, around 100 million Kelvin, but it is not yet hot enough to fuse helium into heavier elements. Instead, it sits inert, supported by electron degeneracy pressure, a quantum mechanical effect that prevents the core from collapsing further. Surrounding this helium core is a shell where hydrogen continues to fuse into helium, providing the energy that powers Arcturus's luminosity. This shell is relatively thin compared to the star's overall size, but it's incredibly active, converting millions of tons of hydrogen into helium every second and releasing the energy. That makes Arcturus shine. Beyond the fusion shell lie the star's convective layers, vast regions, where energy is transported outward not by radiation, but by physical circulation of the hot plasma. Imagine enormous currents of stellar material rising from the interior toward the surface, cooling as they rise, then sinking back toward the core as they're replaced by hotter material from below. These convective currents are each larger than our entire solar system, slowly churning the stellar material in a process that takes thousands of years to complete. The outermost layers of Arcturus form what we think of as the star's surface, though this surface is unlike any surface we experience on Earth. There's no solid boundary, no sharp transition between the star and space. Instead, there's a gradual transition from the dense plasma of the stellar interior to the thin gas of the stellar atmosphere, which itself gradually fades into the vacuum of interstellar space. This atmospheric structure is complex and beautiful, consisting of several distinct layers. The photosphere is the region from which most of the star's light escapes. It's what we see when we look at Arcturus with a telescope. Above the photosphere lies the chromosphere, a region of slightly lower density where the temperature actually increases with altitude, creating conditions for some of the most beautiful phenomena in stellar physics. Beyond the chromosphere lies Arcturus's corona, an extremely hot, tenuous region where temperatures can reach millions of degrees, despite the relatively cool photosphere below. This corona is the source of Arcturus's stellar wind, a stream of charged particles that flows outward from the star at speeds of hundreds of kilometers per second, carrying away mass and energy and gradually reducing the star's total mass over time. The stellar wind from Arcturus is much more vigorous than our sun's solar wind. While our sun loses about 1 Earth mass worth of material every 150 million years, through its solar wind, Arcturus loses mass at a rate roughly 100 times faster. Over its lifetime, as a red giant, Arcturus will lose a significant fraction of its total mass to space material that will eventually become part of the interstellar medium and possibly contribute to the formation of future stars and planets. This mass loss has important implications for Arcturus's future evolution. As the star sheds its outer layers, it's gradually revealing deeper, hotter regions of its interior. Eventually, Arcturus will lose so much of its envelope that it will no longer be able to sustain the shell, burning that currently powers its luminosity. At that point, the star will contract and heat up, becoming what astronomers call a horizontal branch star or possibly an asymptotic giant branch star, depending on its exact mass and evolutionary path. The ultimate fate of Arcturus depends on its precise mass, which astronomers estimate to be about 1 times that of our Sun. This places Arcturus right at the boundary between stars that end their lives as white dwarf stars, and those massive enough to explode as supernovas. Most likely, Arcturus will eventually shed its outer layers entirely, creating a beautiful planetary nebula, a glowing shell of gas illuminated by the hot white dwarf star that remains at its center. This future transformation is still millions of years away, giving us plenty of time to appreciate Arcturus in its current magnificent state. The star we see today represents a perfect balance between stellar youth and stellar death, a mature giant that has successfully navigated the first major crisis of stellar evolution, while retaining enough mass and energy to continue shining brightly for ages to come. The chemical composition of Arcturus tells a story of cosmic evolution that spans billions of years. Like all stars of its generation, Arcturus formed from gas that had already been enriched by previous generations of stars. When the first stars in our galaxy formed over 13 billion years ago, they were composed almost entirely of hydrogen and helium, the only elements created in significant quantities during the Big Bang. But these first-generation stars lived fast and died young, many of them exploding as supernovas that scattered heavier elements throughout the galaxy. By the time Arcturus formed 7 billion years ago, the interstellar medium from which it condensed contained small but significant amounts of carbon, nitrogen, oxygen, silicon, iron, and other elements created by previous stellar generations. Today, Arcturus' atmosphere contains about 0.7% heavy elements by mass, less than our Sun's 1.4%, reflecting its greater age and formation from less enriched material. This slight deficiency in heavy elements is actually one of the clues that helped astronomers determine Arcturus' great age and its membership in what is called the thick disk population of our galaxy. The thick disk is a component of the Milky Way that contains some of our galaxy's oldest stars, formed when the galaxy itself was younger and more turbulent than it is today. Stars in the thick disk, like Arcturus, have orbital motions that are different from younger stars like our Sun. They move in more elliptical orbits that carry them above and below the galaxy's main disk, and they have higher velocities relative to the galactic center. Arcturus is actually moving through our local region of the galaxy at a speed of about 120 kilometers per second relative to nearby stars, fast enough that it will eventually leave our neighborhood, entirely continuing on its elliptical orbit around the galactic center. In a few million years, Arcturus will be too far away to serve as a prominent beacon in Earth's sky, though it will continue its stellar evolution regardless of whether anyone is around to observe it. This motion through the galaxy also means that Arcturus has seen parts of the Milky Way that our Sun never has and never will. Over its 7 billion year lifetime, Arcturus has completed dozens of orbits around the galactic center, sometimes venturing far from the galactic disk into the sparse regions of the halo, sometimes plunging through the denser spiral arms where star formation is most active. Each of these orbital excursions would have exposed Arcturus to different conditions, varying amounts of interstellar dust and gas, different levels of cosmic radiation, occasional close encounters with other stars or stellar remnants. Yet through all of this cosmic wandering, Arcturus has maintained its integrity as a star, steadily converting matter into energy while slowly evolving toward its eventual fate as a white dwarf. The magnetic field of Arcturus adds another layer of complexity to this stellar giant. Like many red giant stars, Arcturus possesses a magnetic field that is weaker than our Sun's, but still significant enough to influence the behavior of the star's atmosphere and stellar wind. This magnetic field is generated by the complex convective motions in the star's interior, creating a dynamo effect similar to, but much more powerful than, the process that generates Earth's magnetic field. The interaction between Arcturus' magnetic field and its stellar wind creates a vast magnetosphere around the star, a region of space dominated by magnetic forces, rather than simple gravitational attraction. This magnetosphere can extend for many times the star's radius, creating a complex environment of charged particles, magnetic field lines, and electromagnetic phenomena that we're only beginning to understand. As we prepare to begin our imaginary journey to this magnificent star, we can appreciate Arcturus as more than just a bright point of light in our sky. It's a complex dynamic system, a stellar giant in the prime of its evolved life, actively converting matter into energy, shedding mass into space, and slowly, but inevitably marching toward its final transformation into a white dwarf surrounded by a glowing planetary nebula. Our journey to Arcturus will take us into this complex stellar environment, allowing us to experience firsthand what it might be like to interact with each layer of this ancient star's atmosphere and interior. We'll discover how the gentle processes of stellar evolution create not destruction, but transformation, a cosmic recycling that ensures the elements of life continue to flow through the galaxy, eventually becoming part of new stars, new worlds, and perhaps new forms of consciousness. Now that we understand our stellar destination, let us begin our peaceful journey across the vast reaches of interstellar space, toward the magnificent red giant Arcturus. Take a slow, comfortable breath as we prepare to leave Earth's vicinity and travel through the cosmic ocean that separates our solar system from this ancient star. Imagine yourself gently lifting away from Earth, not in any violent rocket-powered launch, but in a serene, dreamlike ascent that carries you peacefully beyond our planet's atmosphere, beyond the moon's orbit, beyond the familiar boundaries of our solar system. Feel yourself becoming a cosmic traveler, free from the constraints of gravity and time, able to journey across impossible distances in perfect comfort and safety. As we begin our voyage, Earth shrinks behind us, first to the size of a basketball, then a marble, then a point of blue light that gradually fades into the stellar background. The Sun, our familiar yellow star, remains bright for much longer, but it too eventually becomes just another star among the countless points of light that surround us in all directions. This is your first lesson in the true scale of the universe. Even our own solar system, which seems so vast when we consider the distances between planets, becomes negligible compared to the interstellar gulfs we must cross to reach other stars. The same space that contains our Sun, all its planets, their moons, and the countless asteroids and comets of our solar family represents barely a tiny bubble in the vast ocean of space that separates us from our nearest stellar neighbors. As we travel outward from our solar system, we pass through what astronomers call the heliosphere, the region of space, dominated by our Sun's influence. Here, the solar wind, that stream of charged particles flowing outward from our Sun, creates a bubble of solar material that extends far beyond the orbit of Pluto. The boundary of this bubble, called the heliopause, marks the edge of our solar system's direct influence and the beginning of true interstellar space. Crossing the heliopause is like stepping from a familiar room into a vast, empty cathedral. The constant background hum of solar wind particles suddenly fades, replaced by the profound silence of interstellar space. Here, matter is so sparse that you might travel for millions of miles without encountering a single atom. The density is far lower than the best vacuum we can create on Earth, yet this seemingly empty space is actually filled with invisible treasures, cosmic rays, magnetic fields, and the faint glow of starlight from billions of distant suns. As our journey continues, we begin to appreciate the true meaning of cosmic loneliness. No human-made object has ever traveled the distances we're crossing in our imagination. The fastest spacecraft ever launched from Earth would take tens of thousands of years to reach Arcturus, and that's assuming they could somehow maintain their course and systems for such an unimaginable duration. Yet this apparent emptiness isn't truly empty. Interstellar space contains what astronomers call the interstellar medium, a thin soup of gas and dust that fills the space between stars. This medium is composed primarily of hydrogen, the most abundant element in the universe, along with smaller amounts of helium and trace quantities of heavier elements created by previous generations of stars. The density of this interstellar medium is incredibly low by Earth standards, roughly 1 atom per cubic centimeter, compared to the 30 billion trillion atoms per cubic centimeter in Earth's atmosphere at sea level. Yet over the vast scales of interstellar space, this thin material adds up to a significant amount of matter. All the stars, planets, and other objects in our galaxy represent only about 10% of its total mass. The other 90% exists as this diffuse interstellar medium. As we journey toward Arcturus, we're actually swimming through this cosmic ocean, our path carrying us through regions of varying density and composition. Sometimes we pass through areas where the interstellar medium is even thinner than average, regions that astronomers call local bubbles, vast cavities in space carved out by the stellar winds and explosions of ancient stars. Other times, our route takes us through slightly denser regions where the material between stars contains traces of dust and complex molecules. This interstellar dust, despite its exotic name, is composed of familiar elements, carbon, silicon, oxygen, and iron, along with many others. These dust grains serve as tiny factories for chemical reactions that can't occur in the high-energy environments of stellar interiors. On the cold surfaces of these microscopic particles, simple atoms combine to form water, methane, ammonia, and even more complex organic molecules that may eventually become the building blocks of life on distant worlds. The journey through interstellar space also exposes us to cosmic rays, high-energy particles that zip through the galaxy at nearly the speed of light. These particles, mostly protons and atomic nuclei, were accelerated to incredible speeds by supernova explosions, stellar winds, and other violent cosmic events. As they pass through us on our journey, They carry with them the signatures of cosmic catastrophes that occurred millions or billions of years ago, making us temporary participants in the galaxy's most energetic processes. The magnetic field that permeates interstellar space adds another invisible dimension to our journey. This galactic magnetic field, though incredibly weak by Earth standards, plays a crucial role in shaping the structure and evolution of our galaxy. It influences the motion of charged particles, guides the formation of new stars, and helps determine how energy and matter flow through the cosmic medium. As we travel farther from home, the stars around us begin to shift their positions relative to each other. This stellar parallax is usually undetectable from Earth because of the vast distances involved. But our imaginary journey covers distances great enough that the familiar constellations would gradually distort and change. Stars that appear close, together from Earth's perspective, reveal themselves to be at vastly different distances, while stars that seemed far apart might actually be neighbors in three-dimensional space. The brightest star in our sky, Sirius, gradually fades as we travel away from our solar system, while other stars, those in the direction of our travel toward Arcturus, slowly grow brighter. We may experiencing firsthand how the appearance of the night sky depends entirely on our location in the galaxy, how the familiar patterns of stars that have guided human navigation and imagination for thousands of years are actually just temporary arrangements visible from one tiny location in space. Months pass in our imaginary journey, or perhaps years, depending on how we measure time during interstellar travel. The Sun has long since faded to just another star among thousands, indistinguishable from our perspective except for our memory of calling it home. Earth, our entire solar system, has become part of the past. A small blue world orbiting an ordinary yellow star somewhere behind us in the growing distance. But ahead, growing slowly brighter with each passing day of our cosmic voyage, Arcturus begins to distinguish itself from the stellar background. At first, it's just a slightly brighter point of orange light among the thousands of stars visible around us. But as we continue our approach, it gradually begins to show its true character, not just brighter than the other stars, but noticeably different in color and quality of light. The warm orange-red glow of Arcturus becomes more apparent as we draw closer, distinguishing it clearly from the blue-white, yellow, and red stars that form the background tapestry of our view. This color difference isn't just aesthetic, it is our first direct evidence of Arcturus' nature. As a cool giant star, its surface temperature revealed by the wavelengths of light it emits most strongly. As our journey continues and Arcturus grows brighter still, we begin to detect its motion through space. Unlike the apparently fixed stars of the background, Arcturus shows a measurable proper motion, a gradual change in position. Relative to distant galaxies and more remote stars, we're approaching a star that's actively moving through our galaxy, carrying us along on its ancient orbital path around the galactic center. The gravitational influence of Arcturus also becomes detectable as we approach, though still incredibly weak compared to the Sun's gravitational pull on Earth. Arcturus begins to exert a measurable force on our imaginary journey. We're entering the star's sphere of gravitational influence, becoming part of its system rather than merely an interstellar traveler, passing through the cosmic medium. This gravitational influence marks an important transition in our journey. We're no longer alone in interstellar space, but approaching a stellar system with its own local environment. Arcturus, like all stars, modifies the space around it through its gravity, its magnetic field, and its stellar wind. We're re-entering a region where the conditions of interstellar space give way to conditions dominated by this single, magnificent star. As Arcturus continues to brighten, it begins to show a measurable disk rather than appearing as a simple point of light. This transition from point source to extended object is gradual but profound. We're re-approaching something so large that even from our still enormous distance, it appears to have size and structure. The red giant is beginning to reveal its true nature as an enormous sphere of glowing gas, far larger than the familiar stars of our experience. The stellar wind from Arcturus also becomes detectable as we approach. This stream of charged particles flowing outward from the star creates a subtle but measurable change in the local environment. The density of particles around us begins to increase slightly, and we start to detect the characteristic signatures of material. that was once part of the star itself, atoms, that were forged in Arcturus' interior and then carried away by the stellar wind to become part of the interstellar medium. Our approach to Arcturus is like approaching a cosmic lighthouse. The star's influence extends far beyond its visible surface, creating a complex environment of particles, fields, and forces that we encounter long before we can see the star's detailed structure. We're entering what astronomers call the star's magnetosphere, a region where Arcturus's magnetic field dominates over the general galactic magnetic field, creating local conditions unique to this stellar system. As we draw closer still, the quality of light around us begins to change. The harsh, white light of distant stars gives way to the warm, orange-red illumination of Arcturus. This isn't just a change in brightness, but a change in the character of the light itself, softer, warmer, more diffuse than the point source illumination we've grown accustomed to during our interstellar journey. The temperature of space around us also begins to rise, though it remains far below what we would consider comfortable by Earth standards. Arcturus' luminosity, 170 times greater than our Sun's, is powerful enough to heat the surrounding space, 2 levels slightly above the cosmic background temperature. We're experiencing our first direct taste of the star's energy output, the fusion-powered radiance that makes Arcturus one of the brightest stars in Earth's night sky. The approach to Arcturus is teaching us about the nature of stars as three-dimensional objects, rather than points of light. We're discovering that a star's influence extends far beyond its visible surface, creating a complex local environment that gradually transitions from the general conditions of interstellar space to the specific conditions created by this particular stellar giant. As Arcturus grows larger and brighter ahead of us, we begin to sense the magnitude of what we're approaching. This isn't just another celestial object, but a world unto itself, a massive sphere of plasma and energy that has been converting matter into light for longer than our solar system has existed. We're approaching something ancient, powerful, and magnificent, yet also gentle in its patient transformation of matter into the light and energy that illuminate the cosmos. Our journey across interstellar space to reach Arcturus has taken us through the fundamental structure of our galaxy, from the familiar environment of our solar system, through the vast reaches of space that separate the stars. We've experienced the true scale of the universe, the profound loneliness of interstellar space, and the gradual transition from the general cosmic environment to the specific influence of our stellar destination. Now, as Arcturus begins to dominate our view, growing from a bright star to a visible disk to something that threatens to fill our entire field of vision, we're ready for the next phase of our journey, the approach to the star itself, where we'll discover what it means to fall into one of the most magnificent objects in our galaxy. As we continue our peaceful approach to Arcturus, the magnificent red giant begins to reveal its true nature as one of the most complex and beautiful objects in our galaxy. Take a deep, slow breath as we prepare to explore the intricate layers of stellar atmosphere that surround this ancient star, understanding how each region contributes to the gentle process of stellar transformation that awaits us. From our current distance, Arcturus no longer appears as a simple point of light, but as a distinct disk glowing with warm orange-red radiance. As we draw closer, this disk grows larger and more detailed, revealing the subtle variations in brightness and color that hint at the complex physical processes occurring within the star's atmosphere. The first thing we notice is that Arcturus doesn't have a sharp edge like a planet or moon. Instead, there's a gradual transition from the darkness of space to the glowing brilliance of the stellar atmosphere. This transition zone represents our first encounter with the star's outermost layer, the corona, a region of incredibly hot, tenuous gas that extends far beyond the star's visible surface. The corona of Arcturus is a wonder in itself, a gossamer envelope of plasma heated to temperatures exceeding 1,000,000 degrees Celsius. Despite being farther from the star's nuclear core than the much cooler visible surface below, this temperature inversion, hotter gas existing above cooler gas, seems to violate our everyday experience, where we expect things to get cooler as we move away from a heat source. The corona's extreme temperature is maintained by the star's magnetic field, which channels energy from the turbulent convective layers below. and deposits it in the tenuous upper atmosphere. Magnetic field lines thread through the coronal plasma like invisible highways, guiding the motion of charged particles and creating complex loops, arcs, and streamers that extend far into space. As we enter Arcturus's corona, we begin to feel the first effects of stellar interaction. The density here is still far lower than Earth's atmosphere, roughly equivalent to a laboratory vacuum, but it is significantly denser than the interstellar medium we've been traveling through. We're transitioning from being visitors from interstellar space to becoming participants in the star's own atmospheric system. The coronal plasma around us is composed primarily of ionized hydrogen and helium, atoms so energized by the extreme temperature that their electrons have been stripped away, creating a sea of free protons, alpha particles, and electrons. This plasma responds to magnetic forces in ways that ordinary matter cannot, flowing along magnetic field lines and creating beautiful, dynamic structures that change on timescales ranging from minutes to days. The magnetic field of Arcturus becomes increasingly apparent as we move deeper into the corona. Field lines that were invisible and barely detectable during our interstellar approach now become major influences on our motion and environment. The plasma around us follows these field lines, creating streamers and loops that give the corona its complex, ever-changing structure. Within the corona, we encounter the source of Arcturus's stellar wind, the stream of charged particles that flows continuously outward from the star, carrying away mass and energy at a rate far exceeding our sun's solar wind. This stellar wind is accelerated by the extreme temperatures and magnetic forces within the corona, reaching speeds of hundreds of kilometers per second as it flows past us toward interstellar space. The stellar wind represents one of the most important processes occurring in red giant stars. Like Arcturus, over the star's lifetime as a giant, this wind will carry away a significant fraction of Arcturus's total mass, gradually exposing deeper layers of the stellar interior, and eventually leading to the star's transformation into a white dwarf surrounded by a planetary nebula. As we continue our inward journey, we approach the transition region between the corona and the chromosphere, the next layer of Arcturus's atmosphere. This transition happens over a relatively short distance, but it represents a dramatic change in physical conditions. The temperature drops from the million-degree heat of the corona to the mere tens of thousands of degrees of the chromosphere, while the density increases by several orders of magnitude. The chromosphere of Arcturus is visible as a thin layer of reddish light, surrounding the star's photosphere, the region we normally think of as the star's surface. The chromosphere gets its name from its color, which comes from hydrogen atoms that have been excited by the star's ultraviolet radiation and emit their characteristic red light as they return to lower energy states. Within the chromosphere, we encounter phenomena that would be impossible in any earthly environment. Spicules jets of hot gas shoot upward from the photosphere below at speeds of tens of kilometers per second, creating a constantly changing forest of plasma fountains that can extend thousands of kilometers above the star's surface. These spicules are driven by the convective motions in the layers below, creating a dynamic interface between the star's interior and its extended atmosphere. The magnetic field continues to play a crucial role in chromospheric dynamics. Magnetic flux tubes, regions where the field is concentrated into rope-like structures, channel the flow of energy and matter between different atmospheric layers. These magnetic structures can become twisted and stressed by the star's rotation and convective motions, occasionally snapping and releasing bursts of energy that heat the surrounding plasma. As we sink deeper into Arcturus's atmosphere, the density continues to increase while the temperature begins to drop toward levels that, while still incredibly hot by Earth standards, represent the relatively cool surface of this red giant star. We're approaching the photosphere, the layer from which most of Arcturus's light escapes into space and which defines what we see as the star's visible surface. The photosphere of Arcturus exists at a temperature of approximately 4,300 Kelvin, hot enough to vaporize any known material, yet cool compared to our sun's 5,800 Kelvin surface temperature. This cooler temperature is what gives Arcturus its characteristic orange-red color. As the star emits most strongly in longer wavelengths of light compared to hotter, bluer stars, the photosphere isn't a solid surface like Earth's ground, but rather a region where the stellar atmosphere becomes opaque to visible light. Below this level, photons of light can't travel very far before being absorbed by atoms in the dense stellar gas. Above this level, photons can escape freely into space. The photosphere is thus defined as the region where this transition occurs, the level from which we can see light escaping directly from the star. As we enter the photosphere, we find ourselves immersed in an ocean of hydrogen and helium plasma, with trace amounts of heavier elements that create the absorption lines astronomers use to determine stellar composition. The pressure here is still much lower than Earth's atmospheric pressure at sea level, but it's thousands of times denser than the corona we passed through earlier. The photospheric environment around us is dominated by convection, vast currents of hot plasma, rising from the star's interior, cooling as they approach the surface, then sinking back down to be replaced by new rising currents. These convective cells are enormous by any earthly standard, each one larger than our entire planet. Yet they represent the smallest scale of convective motion in Arcturus' interior. The granulation pattern created by these convective cells gives the photosphere a mottled appearance, like the surface of boiling water viewed from above. Bright areas represent regions where hot plasma is rising from below, while darker areas mark regions where cooler plasma is sinking back toward the interior. This continuous circulation helps transport energy from the star's nuclear core to its surface, where it can be radiated away as light. Within the photosphere, we begin to encounter the products of nuclear fusion more directly. While the fusion reactions themselves occur deep in the stellar core, their products, helium nuclei, neutrinos, and gamma-ray photons, gradually work their way outward through the star's interior. The gamma rays, in particular, undergo countless interactions with stellar material, gradually losing energy and changing wavelength as they random walk through the dense interior. By the time these photons reach the photosphere, they've been transformed from high-energy gamma rays into the visible and infrared light that we see as starlight. Each photon we encounter in the photosphere began its journey in Arcturus' core thousands of years ago, gradually working its way outward through collision after collision with atoms in the stellar interior. The photosphere also contains evidence of Arcturus' advanced evolutionary state. Spectroscopic analysis reveals that convective mixing has brought material from deep within the star to its surface, material that has been processed by nuclear fusion reactions. Elements like carbon and nitrogen show abundance patterns that tell the story of the star's nuclear history, revealing which fusion reactions have been active during Arcturus' long life. As we sink deeper into Arcturus, moving below the photosphere into the star's interior, the density and temperature begin to increase dramatically. We re-entering the convective envelope, the vast region that extends from just below the photosphere nearly to the star's core, where energy transport occurs primarily through the physical motion of stellar material rather than radiation. The convective envelope is where Arcturus truly reveals its nature as a giant star. This region occupies the majority of the star's volume, creating the enormous size that distinguishes red giants from main sequence stars. Within this envelope, convective currents operate on scales that dwarf anything in our earthly experience. Circulation patterns that take thousands of years to complete, and involve the movement of material masses larger than our Sun. The temperature in the convective envelope rises steadily as we move toward the center, from the 4,300 Kelvin of the photosphere to tens of millions of degrees in the inner regions. The pressure increases even more dramatically, rising from the near vacuum of the photosphere to pressures millions of times greater than Earth's atmospheric pressure. Yet despite these extreme conditions, the convective envelope maintains a relatively gentle density gradient. The stellar material here is still composed primarily of hydrogen and helium, but it exists in a state of complete ionization, a plasma where atoms have been stripped of their electrons by the extreme temperature and pressure. This plasma behaves like a fluid, flowing and circulating in response to temperature differences between different regions of the star. Within the convective envelope, we're carried along by these massive circulation currents, experiencing the slow but inexorable mixing that characterizes giant star interiors. Material that was once part of the star's surface layers gets carried deep into the interior, while material that was once near the core gets transported outward toward the photosphere. This mixing is part of what allows giant stars to bring nuclear-processed material to their surfaces, changing their chemical compositions over time. The journey through Arcturus's convective envelope is like traveling through an ocean of plasma, with currents and flows that operate on scales impossible to comprehend from our human perspective. Yet the physics governing these motions are the same basic principles of fluid dynamics that create weather patterns on Earth scaled up to stellar proportions, and operating in a medium heated by nuclear fusion and compressed by the weight of an entire star. As we approach the inner boundary of the convective envelope, we encounter the shell where hydrogen fusion is actively occurring. This is the region that powers Arcturus's luminosity, where hydrogen nuclei are combined into helium nuclei in a process that releases the energy responsible for the star's light and heat. The fusion shell is relatively thin compared to the star's overall size, but it's incredibly active. Here, temperatures reach 20 to 30 million Kelvin, hot enough for nuclear reactions to proceed at the rates necessary to power a giant star's luminosity. The fusion processes here are similar to those occurring in our Sun's core, but they reoccurring in a shell surrounding Arcturus's inert helium core, rather than in the center of the star. Finally, at the heart of Arcturus, we encounter the helium core, the dense, hot remnant of the star's main sequence lifetime of hydrogen burning. This core contains roughly 20% of Arcturus's total mass compressed into a region no larger than Earth. It's supported not by nuclear fusion, but by electron degeneracy pressure, a quantum mechanical effect that prevents further collapse. Even under the enormous gravitational forces at work, the core temperature is around 100 million Kelvin, approaching but not quite reaching the temperature necessary for helium fusion. In the future, as Arcturus continues to evolve, this core will eventually become hot enough to ignite helium burning, leading to another dramatic phase of stellar evolution. But for now, it remains inert, a dense ball of helium plasma waiting for its turn to fuel the star's nuclear fires. Our journey into Arcturus reveals the star as an incredibly complex, dynamic system, far from the simple ball of gas that stars might appear to be from a distance. Each layer of the stellar atmosphere and interior has its own unique physical conditions, its own role in the star's evolution, and its own contribution to the processes that make Arcturus shine. The transformation we experience by falling into Arcturus isn't a violent destruction, but a gradual integration into these stellar processes. Our atoms become part of the convective currents, the nuclear reactions, the energy transport mechanisms that make the star function. We become participants in stellar evolution itself, contributing our small part to the cosmic recycling that has been going on for billions of years, and will continue for billions more. Act 5, the stellar experience and beyond. As we complete our gentle journey into the heart of Arcturus, let us explore what it truly means to become part of a star, not as a catastrophic event, but as a profound transformation that connects us to the deepest processes of cosmic evolution. Take a peaceful breath as we contemplate this ultimate merger with stellar physics, understanding how our atoms join the ancient dance of nuclear fusion and stellar winds that has been shaping the galaxy for billions of years. Within the nuclear furnace of Arcturus, we discover that we haven't been destroyed, we've been transformed into something far more fundamental and eternal. The atoms that once composed our bodies, our thoughts, our dreams, have become part of the star's nuclear processes, participating in the fusion reactions that create light and energy, contributing to the stellar winds that carry material across interstellar space, joining the convective currents that transport energy from the core to the surface. This transformation reveals a profound truth about the nature of existence in the universe. We are not separate from the cosmic processes around us, but temporary arrangements of stellar material that have briefly achieved consciousness before returning to the stellar cycles that created us. The calcium in our bones was forged in the core of an ancient star like Arcturus. The iron in our blood was created in the nuclear furnace of a star. that exploded as a supernova billions of years ago. The oxygen we breathe was manufactured in the interior of massive stars during their final moments of nuclear burning. By falling into Arcturus, we were essentially coming home, returning to the stellar environment that created the elements of which we recomposed. Our atoms rejoined the nuclear processes that gave them birth, participating once again in the fusion reactions that convert hydrogen into helium and release the energy that makes stars shine. Within Arcturus's fusion shell, we experience nuclear physics at its most fundamental level. Here, protons, the nuclei of hydrogen atoms, overcome their natural electromagnetic repulsion through the quantum mechanical process of tunneling, allowing them to get close enough for the strong nuclear force to bind them together. This process requires temperatures of tens of millions of degrees and pressures millions of times greater than anything found on Earth's surface. The fusion process itself is elegant in its simplicity yet profound in its implications. The hydrogen nuclei combine to create one helium nucleus, but the helium nucleus weighs slightly less than the hydrogen nuclei from which it was formed. This small difference in mass, about 0.7% of the original mass, is converted directly into energy. According to Einstein's famous equation E equals mc, the speed of light squared is an enormous number. So even this tiny mass difference creates tremendous amounts of energy. As our atoms participate in these fusion reactions, we become part of the process that powers not just Arcturus, but all the stars in the universe. We're contributing to the same nuclear fires that have been burning for billions of years, creating the light that illuminates galaxies and the energy that makes life possible. On countless worlds throughout the cosmos, the energy we help create in Arcturus's core begins an extraordinary journey toward the star's surface in the form of high-energy gamma-ray photons. This energy must travel through the dense stellar interior, colliding repeatedly with atoms and gradually losing energy with each collision. What began as a gamma-ray might become an X-ray after thousands of collisions, then ultraviolet light after thousands more, eventually emerging as the visible and infrared light that we see as starlight. This journey from core to surface takes thousands of years to complete, meaning that the light we helped create during our fusion experience won't reach Arcturus' surface for millennia to come. Yet when it finally does escape into space, it will carry with it a tiny fraction of the energy that we contributed to the star's nuclear fires, traveling across light years of space to potentially warm distant planets or provide the energy that sustains life on worlds we can't imagine. But fusion isn't the only process we participate in within Arcturus. Some of our atoms join the star's convective currents, becoming part of the massive circulation patterns that transport energy throughout the stellar interior. These currents operate on timescales of thousands of years, carrying material from near the core toward the surface, then back again in an endless cycle of stellar mixing. Through convection, we experience the star as a dynamic, living system rather than a static ball of gas. We're carried upward toward the surface on currents of hot plasma, cooling as we rise and eventually sinking back toward the interior as our density increases. This mixing process gradually homogenizes the stellar interior, ensuring that nuclear processed material eventually makes its way throughout the star. Other atoms that were once part of us join Arcturus' stellar wind, the stream of charged particles that flows continuously outward from the star's corona. Through this process, we become part of the interstellar medium, traveling across vast distances to potentially become part of other stellar systems, other worlds, other forms of life that may rise in the distant future. The stellar wind from Arcturus is particularly vigorous, carrying away about 1 Earth mass worth of material every 10 million years. This mass loss is gradually reducing the star's total mass while enriching the interstellar medium with processed material from the star's interior, elements that were created by nuclear fusion in previous generations of stars, incorporated into Arcturus when it formed 7 billion years ago, are now being returned to space to eventually become part of new stars and planets. Through the stellar wind, we become cosmic ambassadors, carrying the nuclear signature of Arcturus across interstellar space. We might eventually be incorporated into molecular clouds when new stars are forming, becoming part of the raw material from which future stellar systems will condense. We might become part of the atmosphere of a distant planet, or the building blocks from which life emerges in a solar system that won't form for millions of years. This perspective transforms our understanding of what it means to fall into a star, rather than being an ending. It is a continuation, a new chapter in the cosmic story of matter and energy circulation that has been going on since the first stars formed over 13 billion years ago. We become part of the galaxy's metabolism, participating in the processes that recycle stellar material and gradually enrich the universe with the heavy elements necessary for planet formation and life. The future evolution of Arcturus adds another dimension to our stellar experience. As a red giant star with a mass similar to our Sun's, Arcturus is approaching several critical phases in its evolutionary development. Over the next few million years, the helium core will continue to contract and heat up until it reaches the temperature necessary for helium fusion, around 100 million Kelvin. When helium burning finally ignites in Arcturus's core, it will happen rapidly and dramatically in an event called the helium flash. The sudden onset of helium fusion will release enormous amounts of energy in a very short time, causing major readjustments in the star's internal structure. The core will expand, reducing the temperature and pressure in the hydrogen fusion shell above it, which will cause the star's outer layers to contract and heat up. This helium flash will mark Arcturus's transition from the red giant phase to what astronomers call the horizontal branch phase of stellar evolution. The star will become smaller, hotter, and bluer than it is today, burning both hydrogen in a shell and helium in its core. This phase will last for several million years, during which Arcturus will maintain relatively stable luminosity and surface temperature. But helium burning produces carbon and oxygen as its end products, and eventually, Arcturus will begin to run low on helium fuel in its core, just as it previously exhausted its core hydrogen. When this happens, the star will evolve onto what's called the asymptotic giant branch, becoming an even larger and more luminous giant than it is today. During its asymptotic giant branch phase, Arcturus will experience thermal pulses, periodic episodes of vigorous helium burning, that will cause the star's luminosity to vary dramatically. These pulses will also drive strong stellar winds that will strip away much of the star's remaining mass, gradually exposing the hot stellar core. Eventually, Arcturus will lose so much mass through stellar winds that it will no longer be able to sustain nuclear burning in its interior. The outer layers will be completely ejected, forming a beautiful planetary nebula, a glowing shell of gas illuminated by the hot white dwarf star that remains at the center. As atoms that were once part of us, we might follow different paths during these future evolutionary phases. Some of us might be incorporated into the carbon and oxygen produced by helium burning, becoming part of the stellar core that will eventually become a white dwarf. Others might be ejected during the thermal pulses, joining the stellar winds that will create Arcturus's future planetary nebula. The planetary nebula phase will create one of the most beautiful objects in the galaxy, a glowing shell of gas expanding into space at speeds of tens of kilometers per second, illuminated by ultraviolet radiation from the hot white dwarf at its center. This nebula will be visible for tens of thousands of years, a monument to Arcturus's stellar lifetime and a source of enriched material for future star formation. The white dwarf that remains at the center of the planetary nebula will be incredibly dense, roughly the mass of our Sun compressed into an object the size of Earth. This white dwarf will be composed primarily of carbon and oxygen, the end products of helium burning in Arcturus's core. It will be supported not by nuclear fusion, but by electron degeneracy pressure, and it will cool slowly over billions of years. As part of this white dwarf, some of our atoms will experience conditions unlike anything else in the universe. The surface gravity will be tens of thousands of times stronger than Earth's gravity, and the material will be so dense that a teaspoon would weigh as much as a car. Yet this incredibly dense object will be stable virtually forever, cooling and fading but never undergoing further nuclear evolution. Other atoms that were once part of us will become part of the planetary nebula, traveling outward at high speed to enrich the interstellar medium with elements that were processed in Arcturus' interior. These atoms might eventually be incorporated into new molecular clouds, becoming part of the raw material from which future generations of stars and planets will form. This cosmic recycling process is one of the most beautiful aspects of stellar evolution. Stars like Arcturus serve as cosmic factories, taking in hydrogen and helium from the interstellar medium and converting them into heavier elements through nuclear fusion. When the stars die, they return this processed material to space, gradually enriching the galaxy with the carbon, nitrogen, oxygen, and other elements that make planets and life possible. Through our participation in Arcturus's evolution, we become part of this cosmic enrichment process. The elements that were once part of our bodies will eventually become part of new worlds, perhaps contributing to the formation of planets where new forms of life will emerge. We become part of the galaxy's ongoing story of chemical evolution, helping to create the conditions that will allow future consciousness to arise and contemplate its own cosmic origins. The timescales involved in these processes extend far beyond human comprehension. Arcturus has been shining for 7 billion years and will continue to evolve for millions more. The white dwarf it becomes will persist for trillions of years, slowly cooling in the darkness of space long after the last conventional stars have burned out, and the universe has entered an era dominated by stellar remnants. Yet our atoms will be part of this entire cosmic story, participating in stellar evolution, galactic chemical enrichment, and the formation of new worlds throughout the universe's future history. We become part of something eternal and beautiful, contributing our infinitesimal but meaningful part to the ongoing evolution of matter and energy that defines the cosmos. This perspective transforms the concept of falling into Arcturus from a catastrophic ending into a triumphant beginning, a return to our stellar origins, and a participation in the cosmic processes that will continue creating wonders throughout the universe's vast future. We don't disappear when we fall into a star. We become part of something infinitely larger and more enduring than our temporary existence. As conscious beings, the beauty of this transformation lies not just in its physical reality, but in its symbolic meaning. It reminds us that we are not separate from the universe around us, but integral parts of cosmic evolution itself. Our existence is made possible by billions of years of stellar nuclear synthesis, and our atoms will continue participating in cosmic processes long after our brief moment of consciousness has passed. Through Arcturus, we learn that the universe is not a hostile void trying to destroy us, but a vast, interconnected system of which we're already a part. The stars are not distant, alien objects, but our cosmic ancestors and descendants, the factories that created our atoms, and the destinations to which those atoms will eventually return. As our extraordinary journey through the stellar interior of Arcturus draws to a gentle close, let's slowly peacefully return our consciousness to Earth, bringing with us the profound insights and cosmic perspective we've gained from our imaginary fall into one of the galaxy's most magnificent red giant stars. Take a slow, deep breath with me as we begin this transition back to our familiar world. Feel yourself gradually becoming aware again of your physical body, your comfortable surroundings, the peaceful environment where you've been resting during our cosmic exploration. But as we return to Earth, we carry with us a transformed understanding of our place in the universe and our connection to the stellar processes that gave us life. Our journey into Arcturus has revealed something beautiful and profound about the nature of existence itself. We've discovered that what might initially seem like destruction, falling into a star, is actually a homecoming, a return to the cosmic processes that created the very atoms from which we're composed. We've learned that we are not separate from the stars we see twinkling in the night sky, but intimately connected to them through the elements in our bodies and the energy that powers our lives. Every breath you take right now contains oxygen that was forged in the nuclear furnace of an ancient star similar to Arcturus. The calcium that gives strength to your bones was created in stellar cores through the same fusion processes we experienced during our journey. The iron in your blood, essential for carrying oxygen throughout your body, was manufactured in the final moments of a massive star's life and distributed through space in a supernova explosion that lit up the galaxy billions of years ago. This means that you are, quite literally, made of stardust, not in a poetic or metaphorical sense, but as a matter of scientific fact. You are a temporary arrangement of stellar material that has achieved consciousness, a way for the universe to become aware of itself and contemplate its own magnificent complexity. Your thoughts, your dreams, your capacity for wonder and love, all of these emerge from matter that was once part of ancient stars processed in nuclear furnaces, and assembled over billions of years into the remarkable complexity that is you. Our exploration of Arcturus has shown us that stellar evolution is not a process of destruction, but of transformation and renewal. When stars like Arcturus reach the end of their lives, they don't simply disappear, they return their processed material to the galaxy, enriching the interstellar medium with the heavy elements necessary for planet formation and life. The death of one star becomes the birth of countless future possibilities. This cosmic recycling process connects all life in the universe to the stellar processes we've explored tonight. The carbon that forms the backbone of every organic molecule in your body was created through helium burning in the core of a red giant star. The phosphorus that enables energy storage and transfer in your cells was produced in the silicon burning phase of a massive star S-evolution. Even the trace elements essential for life, the zinc in your enzymes, the cobalt in your vitamin B12, the molybdenum that enables nitrogen fixation in plants, all were created in stellar interiors and distributed through space by stellar winds and supernova explosions. This understanding transforms our relationship with the night sky. When you look up at the stars on a clear evening, you're not observing distant alien objects, but seeing your cosmic family, the stellar ancestors that created your atoms, and the stellar descendants that will receive those atoms when they're eventually returned to the cosmos. The warm orange glow of Arcturus, visible to the naked eye on spring and summer evenings, is light from a star that demonstrates the same evolutionary processes that created the elements essential for your existence. The timescales involved in stellar evolution also provide a profound perspective on our human experience. Arcturus has been shining for 7 billion years, longer than Earth has existed, longer than life has flourished on our planet. It will continue to evolve and transform for millions of years more, eventually becoming a white dwarf that will persist for trillions of years. Against these cosmic timescales, our human lives appear incredibly brief, fleeting moments in the vast sweep of cosmic time. Yet this perspective doesn't diminish the importance or meaning of our existence. Instead, it reveals how extraordinary it is that the universe has evolved to the point where matter can become conscious and contemplate its own origins. Out of the simple hydrogen and helium created in the Big Bang, through billions of years of stellar evolution and planetary formation, the cosmos has created conscious beings capable of understanding their place in the cosmic story. You represent one of the universe's greatest achievements, matter that has become aware of itself, capable of wonder, love, creativity, and understanding. Your consciousness is a way for the cosmos to experience itself subjectively, to know beauty and meaning from the inside rather than just existing as an objective physical process. Our journey into Arcturus has also revealed the fundamental interconnectedness of all things in the universe. The same nuclear processes that power the star's luminosity operate according to the same physical laws that govern the chemistry of life on Earth. The gravitational forces that maintain Arcturus' structure also keep Earth in its orbit around the Sun and hold our galaxy together. The electromagnetic forces that create Arcturus' magnetic field also enable the chemical bonds that make life possible. This interconnectedness extends beyond physics to include our shared participation in cosmic evolution. We are not observers of the universe looking in from the outside, but participants in cosmic processes, temporary but meaningful arrangements of matter and energy that have emerged from stellar evolution and will eventually return to it. Our lives are brief chapters in the ongoing story of cosmic development, but they are chapters that matter, that contribute meaning and consciousness to the universe's evolution. The beauty we found in our journey through Arcturus, the elegant physics of stellar structure, the graceful processes of nuclear fusion, the patient rhythms of stellar evolution, reflects a deeper beauty inherent in the cosmos itself. The universe is not a random collection of matter and energy. but an interconnected system governed by elegant mathematical laws that create complexity, beauty, and ultimately consciousness. This cosmic beauty is accessible to us not just through scientific understanding, but through direct experience of the natural world around us. Every sunset displays the same physics of light scattering that creates the red color of eclipsed moons and the orange glow of red giant stars. Every tide demonstrates the gravitational forces that govern stellar evolution and galactic structure. Every growing plant captures energy from nuclear fusion occurring 93 million miles away in the sun's core. As we complete our return to Earth consciousness, I want you to carry with you this sense of cosmic connection and participation. You are not separate from the universe around you, but an integral part of its ongoing evolution. Your existence is made possible by billions of years of cosmic development, from the formation of the first stars to the evolution of our sun and solar system to the emergence of life and consciousness on Earth. This understanding can provide profound comfort during difficult times. When you feel isolated or insignificant, remember that you are connected to every star in the galaxy through the atoms in your body. When you face challenges or uncertainty, remember that you are part of a universe that has been successfully evolving and creating beauty for nearly 14 billion years. When you wonder about your purpose or meaning, remember that you are consciousness itself, the universe's way of knowing and appreciating its own magnificent complexity. The future holds infinite possibilities for cosmic evolution and human participation in that evolution. Our species is young. Modern humans have existed for only a few 100,000 years, a brief moment in cosmic time. We have the potential to become a truly cosmic civilization, spreading life and consciousness throughout the galaxy, participating actively in stellar engineering and cosmic evolution. Perhaps someday, human descendants will have the technology to actually visit stars like Arcturus, not in imagination but in reality. Perhaps we'll develop ways to harness stellar energy directly, or even to influence stellar evolution for our own purposes. Perhaps we'll seed new solar systems with life, becoming active participants in the cosmic recycling that has been proceeding naturally for billions of years. But even if our species never achieves such cosmic ambitions, we are already participants in something magnificent simply by being conscious, by being able to understand and appreciate the universe of which we're part. Every moment of wonder you experience when looking at the night sky, every insight you gain about cosmic processes, every appreciation of natural beauty represents the universe becoming aware of and appreciating itself. The night sky will never look the same to you after our journey to Arcturus. When you see the warm orange star blazing in the constellation Boats, you'll remember our exploration of its stellar interior, our participation in its nuclear processes, our transformation from separate entities into integral parts of stellar evolution. You'll understand that the light entering your eyes began its journey in nuclear reactions, similar to those we experienced, carrying energy that was created by the same fusion processes that created the elements in your body. On clear evenings, when you can see the Milky Way stretching across the sky, you'll remember that this is our galaxy, the vast collection of stars, gas, dust, and dark matter of which we are all part. You'll understand that the stellar processes we explored in Arcturus are occurring in billions of stars throughout our galaxy, creating the elements necessary for planets and life, recycling matter and energy in an endless cycle of cosmic renewal. As you prepare for sleep tonight, or whenever you choose to rest, carry with you the peaceful knowledge that you are at home in the universe. You are not a stranger in a hostile cosmos, but a beloved child of stellar evolution, created by the same processes that power the stars and composed of material that has been part of the cosmic story for billions of years. Let the gentle rhythms of stellar evolution, the patient burning of nuclear fuel, the slow circulation of convective currents, the gradual recycling of matter through stellar winds, become a source of peace and perspective in your daily life. These cosmic processes remind us that we are part of something timeless and beautiful, something that transcends our temporary concerns and connects us to the fundamental creative processes of the universe. The red giant Arcturus continues its ancient evolution, patiently converting matter into energy, slowly shedding its outer layers to space, gradually approaching its transformation into a white dwarf surrounded by a glowing planetary nebula. It has been doing this work for longer than Earth has existed, and it will continue long after our current civilization has become part of cosmic history. Yet, in our brief moment of cosmic consciousness, we have been able to understand and appreciate Arcturus' stellar evolution, to imagine ourselves participating in its nuclear processes, to find meaning and beauty in our connection to stellar physics. We have demonstrated the universe's capacity for self-awareness, its ability to know itself through conscious beings like ourselves. Thank you for joining me on this profound journey into the heart of a star, this exploration of what it might mean to fall into Arcturus and become part of stellar evolution itself. May the insights we've shared tonight bring you peace, wonder, and a deeper appreciation of your place in the magnificent, interconnected cosmos we all call home. Sweet dreams, fellow stardust. Remember that you carry the universe within you, that you are both created by rest well in the knowledge that you are home in the universe, forever connected to the stellar processes that gave you life and to which you will someday return, contributing your atoms to future chapters of the cosmic story that began with the Big Bang and will continue for unimaginable eons into the future. The stars are calling you home, but you're already there, already part of the eternal dance of matter and energy that creates and sustains all beauty in our magnificent universe.